Alright, and we are live. I'm liking the face streams again. So I'm gonna do a couple more face streams, even though like less monitors. But I like them. Anyways, I have been having trouble locking in and getting over the compiler portion of the project. Actually like locking in and like let's go from the AST to intermediate representation. Like, let's just lock in and do it. So I'm like, you know what? I don't know that starting a stream at 9 p.m. when I want to fix my sleep schedule sometime relatively soon is the best idea. However, however, it I will probably get it done if I just lock in and stream. So that is what we are doing. Oh, is the printer finally going to print stuff? Yeah. Okay. One second. That's actually, I should probably go do that. It's charging my car battery. I'm going to go unplug my car, so my car battery is not charging overnight. That would be bad. But my timer to remind myself to do that was going to go off in 30 seconds. So I'm gonna go do that and then be back. Alright, I'm back. You might be wondering, Mr. Wireless, why, pray tell, did you need to charge your car's battery? It's not actually because my car's battery is bad, it's because I accidentally left the light on for several days. It was the second time I've had to fully recharge my car's battery from completely dead. because I am stupid. Also, doesn't help that the car is 20 years old, so it is susceptible to things like that, but that's kind of like an any car thing. Anyways, okay, let's see. Yes, back to stream. It's also raining outside right now, which is fun. Okay. So to kind of recap where I'm at right now. So does it compile right now? So Brane backend LLVM does not compile. Okay, yeah, there's some changes I need to make to the main Brane C. Let me just revert this back. So that I can show off what it do. And I'm going to comment out those for now. And then we should be able to cargo run this. They're going to complain about the backend. It is. So I'm going to temporarily remove that from the workspace. Actually, is CLI dependent upon backend? It is not yet. So that should be fine. Brane C source. Okay, so that's the same file as before. IRF does not exist anymore. And that's also because I'm refactoring the AST at the moment as well. Okay, did it run? It did. Okay, let me show you the script it is currently running. Oh, come on. Link the pages, there we go. Yep. So I just have an example script like this that I think tests out the vast majority of my code paths. So there's a function definition, there's an enum definition, there's a struct definition, and there's a pipeline definition. So this tests most of the things. This tests most of the things that we need to test. So we just have a pipeline that takes in two structures that are myStruct And then it... Wait a second, I'm doing add enum on... We'll just hyper stress test this by having this be... Apparently this is going on at the same time as DEF CON After Dark stream. I'm aware of the WAN show After Dark stream, but... Too much of a stereotype. I don't know that it's a stereotype. I know, like, After Dark streams. Like, vaguely. Would this count as an After Dark stream? Because it is dark outside. It is 9 p.m. Okay, but yeah. So basically your simple add stuff together script. But we have a structure with enums. So this is like, if we get this compiling, our stuff is working. Like, all of our stuff is working. If we get this compiling. And the stuff that actually matters, not the stuff I was focusing on before, which was operators. Operators are the easiest thing to add. This actual structure, the stuff we care about, all of this stuff, the stuff that we'll have to figure out to get this script to compile, is what we're gonna do today. By doing two things. We're gonna have to change up the intermediate representation. So, one thing I want to do is I want to reevaluate, like, what actual operands I have here. And how they interact with each other. And I already did that a little bit. I know DEF CON, yeah. To my knowledge, DEF CON is the largest security-focused conference. Like, cybersecurity-focused conference. I mean, it's the one everybody knows about. But yeah, so... Yeah, this is currently what I think of as the form of code that's easiest to go from this code, this format here, to an actually compiled binary. Now, with one caveat, and that caveat, here, one second, I'm gonna face cam real quick, because I don't know which... Where's my face cam? There it is. Because I don't know which Notion page this is going to open up to when I open up Notion. And it's a good thing I did that. Because that is a different organization. Let's open up this. Go to here. Script MVP C-like. And we might want to open up a new... planning document for this, because this also okay, back to screen capture. Yes, seems like hackers seem to be split on whether to lean into look or to cringe at the edgy teenager thing. I say lean into it, but yeah, there are always the suit wearers who are like, no, I'm not edgy. Usually the difference is between people who like actually know how to have fun and those who don't. Who is boring and who isn't. Okay, Brane script, IR, and backend. So this is the part that we do actually need to design well, because this is the part where mistakes made here exist forever. Because IR is what we're going to be storing on the server, mostly. Like, when you ship a binary, the Brane script IR is what's going to continue to exist, and the backend is what's on the client that actually runs it. And the most important problems are security of memory access, and some like sub items of that are bounds checking pointer operations, basically making sure they don't access memory. Why are you awake at 3 a.m. your time? See, I would stream during the day if I was awake during the day. So we have bounds checking pointer operations, enforced immutability, and I've already solved these two with the way that I do, with the way that I have pointers set up. Mostly, let's see, where is my Mac charging cable for this laptop? I don't think it's gonna run out of power, but like, I don't want it to run out of power. Oh well, no cable. If chat dies, it dies. Not the only one crazy enough to develop a game engine, and that crazy has. This is true. Well, yeah, so security of memory access. This is kind of the most important thing. Then after that, it's how to handle stack versus heap. Which this is like, I have not figured out how to handle stack versus heap. And the reason why it's important for us to figure this out is because we need to handle structures manually. So I'm just going to say structure handling, and structure handling includes function call ABI, structure handling deals with function calling conventions. It deals with where our structs allocated. And the reason why it's important to care about where structs are allocated is because depending on where a structure is allocated, we need to handle pointer operations like member access operations differently. I don't know if I have a member access operation. I used to have an explicit like access this member of the struct and like reference the struct definition to do that. I don't have one of those operations in here anymore, and we're just like directly emitting operations to do with like loads from a pointer, stores a value to a pointer. These values are implicitly all kind of like either stack or heap values. They're like, so in LLVM and Crane Lift, you get this concept of a value, and then you let the back end of those systems decide where it wants to actually store that variable. And the problem is that variable might not have an actual memory location unless you explicitly allocate it on the stack or the heap, but then you need a way to allocate things on the heap. Yeah, and like allocators like malloc, they're not built into LLVM or any of these JIT functions. You need to import that externally, so that is something you have to figure out. All right, sleeping is good. Do that. Hello, SquarePeg. How goes it? Yeah, I don't want to do everything on the heap because I want things to be fast. However, we might do, one of our options is an emulated heap where we bind memory pages and treat them as a stack. So they really are heap allocated, but we treat them like a stack. But then, like, I'm worried about how that, because we're not running LLVM optimizations, so then we're kind of stuck with that as like the final. It might not be as efficient. So we might have to make our intermediate representation a slightly higher level than it currently is to be able to account for stuff like pointers, enums, where I don't necessarily, because like, think about it. Let's say you have an enum with two variants. One of the variants is actually, because of how I handle pointers, you are physically unable to do out of bounds memory access. So I don't need to worry about people doing weird workarounds with like enum access to like get pointers that don't exist. That's something I don't need to worry about. In fact, I should just, as long as pointers are fine, function calls are fine, and pipeline scheduling, as long as those four are safe, the rest of the code should not need to be able to, like, should not need to be safe. The runtime should be able to completely sandbox any other error that could occur. And we'll use platform native handling for that sort of stuff. Because I am still keeping the functional programming idea, but only at the pipeline level. So pipeline stages can have no side effects, but within the code itself, the memory that they're passed, they can do whatever they want with that. Mostly. I think the inputs to a pipeline, I don't know if I want to do pipeline stage or just pipeline general. Depends on how sensitive certain things are. But generally, the input to pipelines is going to be immutable, and then the output is formed from that, and then we'll have runtime enforced immutability, so it's physically impossible to emit a script that is able to access memory that we have not given it access, or write access to. And that is going to be not even a runtime check. That is going to be like a structural thing that you won't be physically able to do that. Let's see how. do member accesses work? Enum handling. How do we access the access and set the value of enums? Let's see. Which means match statements for extracting values. But are those match statements enforced at the runtime level? Are those enforced at the runtime level, or do we allow those to fail? What are your favorite technical books on your bookshelf back there? So this is the family bookshelf, not mine. So I didn't have too much of a say of anything. Let's see. What books did I used to spend a lot of time looking at? There's one in particular. Yes. I've had different versions of this book, but I love this book. And just like mostly the like cross sections of, yeah, it's like the pages like this. That was when I was like super young though. It's like a book on like Visual Basic back there that I like occasionally picked up and didn't understand at all because I was too young to understand it. My old HTML, CSS, and JavaScript for Dummies book might be there. That's what started my coding journey. But yeah. What's your favorite tech book you've ever read in general? I have an immediate answer to that. Called The Nature of Code, and you can read it for free online. This book is why I am the way that I am. So this is the way that I learned how to code. So start off with like mostly, so I made some websites by copying out of books. But then I didn't actually like really get into coding until like Khan Academy basically. And this is the book that all of their courses are based off of. So the actual, like, the way that I learned how to code was through this book. And it didn't necessarily teach you coding as much as, like, how to model the real world with code. So, like, this is why I, like, got an A in geometry, was because of the chapter on vectors. And like the reason I understand physics as well as I do is because of the forces. And then of course there's like particle systems, some stuff on like Boyd's simulations. They even have like, this book is like really good. They even have a thing on like neural networks, how to write your own neural network. And this book came out... When did this book come out? I'm not sure. But yeah, the end of the book gets to you making entire ecosystems using evolutionary algorithms and It didn't have Flappy Bird in the one I had. I think I got to the neat chapter was maybe the last one. But yeah, it talks about like reinforcement learning and whatnot. So this, like, I would read this book, like physical book, for hours, as like a 14, 13-year old. And I have like physical bookmarks in it and stuff. This is like the only code book that I have fully like ever gotten through, and it is the way why I am the way that I am. And like eventually I'm going to go back into like force feedback haptics, and can rely on my knowledge of that book of like forces and whatnot. At some point, if I become an AI bro, my foundation of like AI was in that book, and how like machine learning works. I can trace so much of everything to that book and reading it as young as I did. Okay, so we have structure handling, we have enum handling. Ooh, very important thing. L value versus R value handling. Yeah. What are IR values, and how are those represented in the final output? This is perhaps the most important question. Can structures and enums be singular values, or are they expressed from how we treat those other values? And additionally, like, what do we expect backends to do for us, and what do we expect let's see, here's the thing. Crane Lift does not have structs. Does Crane Lift have SIMD? Okay, Crane Lift does have SIMD types. Okay. Now, I don't think I'm going to support, at least at first, automatic upgrading to SIMD, but I am going to have intrinsics for SIMD that should be supported. So every system should be able to handle SIMD commands. Whether they actually emit SIMD commands or not is up to them. So we must create our own function calling conventions. This is the biggest thing. One of the bigger things. Let's see. See how variables work in Crane Lift. Because this is the most important thing. With LLVM, it's you have a memory address, and then that memory address, you can do load and store operations to that memory address. And that's the easiest way to represent a variable, because you're just like, if you want to change the variable, you do a store operation. If you want to read the variable, you do a load operation. I want to be more efficient than that. I want to avoid explicit need for memory. Using ephemeral values is what I'm going to call it. They're really called SSA values. But I saw something in the CraneLift docs. Well, here it is. It's the first thing. The most interesting thing about this API is it provides a single way to deal with all your variable problems. Indeed, the function builder struct has a type variable, which should be an index of your source language variables. Then, through calling the functions declare variable, declare var, def var, and use var, the function builder will create for you all the CraneLift IR values corresponding to your variables. This API has been designed to help you translate your mutable variables into SSA form. The use var will return the CraneLift IR value that corresponds to your mutable variable at a precise point in the program. However, if you know beforehand that one of your variables is only defined once, for instance, if it is the result of an intermediate expression in an expression-based language, then you can translate it directly by the CraneLift IR value returned by the instruction builder. Using useVar API for such an immutable variable would also work, but with the slight additional overhead. The SSA algorithm does not know beforehand if a variable is immutable or not. The moral is that you should use these three functions to handle all your immutable variables, even those that are not present in the source code, but artifacts of the translation. It is up to you to keep a mapping between the mutable variables of your language and their variable index that is used in CraneLift. Caution, use the variable as the variable is used by CraneLift to index an array. Okay. So we don't need to use their variable API, because behind the scenes, what the variable API is doing, so you use builder use var. This is getting the current SSA graph node corresponding to the value of that variable at that time. I like the API, but I don't think we use it from CraneLift. I think we create it compiler side when we're emitting our own intermediate representation, and then we re-expose it. We recreate it CraneLift side, and then that should work for both of them. The one thing I do want to copy from CraneLift, though, is how control flow works here. How to handle control flow. So we need to add in the concept of a basic block, and how to handle phi nodes. Basically, everywhere that this node is called from, like every single place that basically a block needs to be aware of every single possible place it's called from before it's emitted, kind of. Are you planning the graph-based scripting? So not right now. We have reverted back to just doing like a regular scripting language. In fact, I've reverted back so far. I spent the last 3 weeks on like this super advanced dependent type system that I want to come back to at some point, but I really just like I want to start working on the engine. So now we basically have reverted back to a C-like language, but with the addition of discriminated unions, which is like a Rust style enum. So it's C, but with a discriminated union, and the syntax looks a little different. Literally make the simplest language possible, but still have a really fast runtime, because that's the main problem I want to solve, is a really fast runtime. I don't need to make the perfect coding language yet. I'll come back to that later. And other people, if they want to create their own compilers for BraneScript IR, that is another thing that I do want to support. Okay. Both LLVM and Crane Lift use SSA graphs. LLVM uses phi nodes. Crane Lift constructs phi nodes for us by passing arguments to basic blocks to jump. So LLVM lets us do whatever we want. LLVM is just something that can represent anything. CraneLift has a more structured jump format. So if we do jump, unconditional jump, you can see we have to pass in arguments, and these are SSA graph values for every single value that could possibly be an argument to that block. Wait, if the scripting language will be transferred to machine code, how will the engine work with it? Through a function pointer. And that's... we are making the fastest scripting language that if we pull it off, it will actually be the fastest scripting language, just from like an architecture level. There will always be like, let's make a better optimizing compiler. Like there will always be optimizations there, and it won't be the greatest there at first. But from an architecture level, we use JIT. So in the same way WASM gets just-in-time compiled down to machine code that is essentially just a function pointer that you would just call like a regular function, without an actual runtime orchestrating things. Now, we will have a runtime for doing thread scheduling, but for actually running the code, no interpreter. It just is a regular function that you call, but that function appears at runtime through the magic of JIT compilation. Just-in-time compilation. So CraneLift is the lowest common denominator here. Their system for basic blocks is more restrictive than LLVM's system for basic blocks. Now, LLVM's system for basic blocks is harder for us to deal with. So here's the thing. I'm going to try to make as much of the... Once we get to actually making the engine, I'm going to write as much of the engine as possible in the scripting language, like Brane script, so we're all going to be on the same level. Aside from, like, the... like, actually changing runtime stuff, I want as much of the, like, behaviors, so, like, UI is written in Brane script. Logic... slower logic is written in Brane script. Brane script will be fast, so it's not totally slower. But, yeah. Anything that we want to be moddable is written in Brane script, so people can swap it out at runtime. I do plan on allowing for client-side modding, because, like, we have a scripting language, so why don't you just let people load scripts just for themselves? Client modding, and as long as, like, the client runtime, well, the networking is what needs to be safe to stop, like, crashers and basically any malicious actors. That's actually the main reason I don't want to do peer-to-peer, is because if you have an authoritative server, just immediately you can stop hackers at the networking level. Peer-to-peer, good luck. That all the X-ray Minecraft mods to cheat at finding stuff. That is a networking problem. Blocks, you would need some way to server-side make blocks that aren't visible to a user, straight up not actually visible to them. So I'm blaming servers, not client mods. If somebody's able to do it, it's the problem of it. Yes, they shouldn't be hacking, but they shouldn't be able to hack to begin with. We compile tonight, indeed. I'm writing out a design document for the intermediate representation, and then we are locking in. Because as soon as I know how the intermediate representation is going to work, once we figure out how the intermediate representation works, we can fly. We can get this all working. It's probably going to be like 2 a.m., not midnight. If we're lucky. Yes, you should. Okay, so basically we're going to copy CraneLift's phi node abstraction, because it is an abstraction. I know behind the scenes they're probably doing the same phi node system. So I guess blocks don't need to be in order, I guess. Straight up blocks don't need to be in order. How you'll prevent hacking in general. The most important thing is for the scripting language to be secure, and I have a couple things like by the way the runtime is designed, you're physically unable to access memory that you have not explicitly been given access to, as well as like the ability to pass memory into that environment and not let people change it at a runtime level. And then from that point on, it's kind of like architectural. Networking is like, I'll have to do like basically a lot of documentation on here's the secure way to do your networking. And I will be mad if you do your networking in these other ways and stuff like that. Make sure that you put like any API keys on the server side code and make sure you have that server side key there, and make sure like variables that you pass to that are only server side. Has achieves for hacking the scripting language. Seems like it does a good job at keeping from. Has achievements for hacking the scripting language. Is that what you're saying? Issues that hosts could be malicious as well. So for that, it's like the latest version of the Brane client will always have like, this is like my plan. I can't make like super guarantees for this, but the client itself will have safeguards of like not totally trusting servers, and servers will have safeguards of not totally trusting clients. So hopefully if somebody like sets up a malicious server, they're not able to run anything on your device. That's down to like the scripting runtime, and that goes for both servers and clients. Like the scripting runtime can't do anything that you don't let it do. And then the other aspect is just like, if the host is malicious, stop going to their world. That's the simplest security thing that you can do, at least in the beginning. But yeah, that's the hard thing, is since it's an open source product, we can't do security through obscurity. So we have to make everything actually secure. If it can be hacked, it will. Yeah, but server hosts would probably have no issue crashing you or DDoSing you. So they would be able to DDoS you and grab your IP. I want to make it so they're not able to crash you. They can disconnect you. They basically have full control over your in-game representation of yourself, but they won't be able to crash you, at least when the engine is working correctly. Because I do want like a client-side protection against either overloading your CPU, VRAM, GPU. Like, the client will refuse to run stuff that it can't, so that will cause like, the world still won't work, but it won't crash your PC. And a lot of that has to do with the scripting language, which is why we're coding the scripting language here. So we want to look at crane lift, not variable. We want to look at where is crane lift? Here we go. Here's an example. Oh, wait. I think we want function builder. Here we go. This is how we build stuff. Do we have block builders? That part of the song always gets me. It sounds like a Discord ping. Unless I was actually Discord pinged. I was not actually Discord pinged. Okay. People could just DDoS the hosts. People can DDoS anything. Yeah. The answer I have to that is like, the VR chat servers were better for the last few days. Yeah. I mean, the only solution to that is to like get something like that's not really a problem I can solve architecturally. Use Cloudflare, their services. Not sponsored. Please sponsor, but not sponsored. So, okay, so this gets set to certain blocks. Oh, we actually do have a jump table. No, this is... So... Oh, this is Udon assembly. No, I was using it to look at a different form of the project and copy paste stuff into it. I now have a copy of Brane script, so I can pull some old stuff from like old versions of Brane script into here. Mainly the emitter and BrainC source stuff, which I can quickly show you what that does, because it's actually pretty cool. So if I make an intentional grammar error, then you can see this error message here is not the output of cargo, even though it looks like this. This is our function output right here, or our program output right here, and we have a really nicely formatted error. So right here, we were expecting struct enum function pipe a namespace use link or an end of input. So yeah, pulled that back because like it like shows a snippet of the code. It's beautiful. Yeah. What is Udon? Udon is the virtual machine that VRChat uses. So I've written a compiler for VRChat. Not for them, but that compiles to VRChat. And the reason I did that was so that I could have Unity event style things in Udon. So I wrote an entire compiler to make nice looking UI. Let's see. Okay. Retrieves all the parameters for a block currently inferred from the jump instructions. Inserted the targeted it and the SSA construction. Wait, type. Is crane lift statically typed? Okay, what is the purpose of a VM in this? So, a VM, virtual machine, that's just another word for the interpreter that runs scripts. In the case of Udon, that's just how like VRChat runs world scripts. Not physics. Physics is built into Unity itself, but that's like anytime you write a script in a world and that does anything. Yeah. Script virtual machine. You can apparently change jump destinations. I don't know how I feel about that. Oh, they have a mem copy function. LVM doesn't have an it doesn't have an M copy. Okay, but I'm not seeing... the ability to emit... About the function instruction? Okay, that's just build. But how do you do actual, like, builder instruction I add? So we need this instruction. Turns an object with the instruction builder, allows to conveniently append an instruction to the current block. Okay. That returns this function instruction builder. Which doesn't have anything. So instruction I add. Instruction builder. Where are all these? Where are the actual instructions? Function instruction builder. With the instruction builder trait, which I believe is what's important here. Let's see, where is... Should say somewhere that it is. Yes. Has implemented instruction builder. Which this has all of our actual instructions here. Don't even need to think about malware when it comes to the potential of sketchy CD use of virtual worlds. Just look at how filled with gambling and blockchain stuff became. Build it and they will come. Yeah, the harmful stuff was in the worlds themselves. Is that what you're trying to say? Okay. Will the engine be built in Brane script? Partially. As much of the engine as I can, I'm going to build it in Brane script. Anything that needs to be fast is going to be built... I'm going to rewrite it in Rust. It's currently a fairly large C++ repository. I don't think it will take too long to move stuff over. In fact, I do need to rewrite the entire code base because I didn't handle errors basically at all. If it crashed while using it, I would fix the source of the crash. And that was my error handling. Stack switch. That is a hell of an instruction. So this has explicit store stuff to and from the stack. Let me ask, does crane lift handle Okay, so they do handle that for me. So basically what I want to do, what do we want to handle explicitly and what do we want to avoid? We want to avoid manually handling stack values. I do not want to have to manually decide what is a stack versus heap value. I want to allow either LLVM or crane lift to... I want to work with ephemeral values as much as possible. Keep values entirely in a form. Except when we must change them. We must have a memory address. Thank you for the good luck. I will need it. Let's see. I feel at this point, if you have a Brane engine, client servers, world search, it would be like the Unreal Engine in Epic Games of VR. Potentially. They have revenue, though. They have an engine that you have to pay them to use. Simpler as with space isn't that it can prevent dystopia, but it can be large enough to also encompass a lot of good in addition to the bad. That's kind of my goal, is like, if I release something like this open source, immediately large corporations don't have control over any one platform anymore. I kind of want to force VR into a better version of WebXR, if that makes sense. Like, let's work on this distributed ecosystem where everybody owns their own stuff. But it's not crypto. Because crypto doesn't solve problems. It attracts grifters. Good evening. Okay, avoid manually handling stack versus heap values. Keep values entirely in SSA form, except when we must. Have a memory address. See, here is the thing. I could have structures handled entirely as ephemeral values. And never have them actually stored. on the heap. Issues that, considering its FOSS, gaming giants would have no issue making a fork and then trying to make it better and monetize it. They would have issues, though. And the issue is, big corporations aren't magic. They don't have magic skilled workers that it can take an engine like this and then just like move on with it and like completely ditch the original project. The problem is companies are made out of people and they have a limited number of skilled engineers, and they have even less skilled engineers after the invention of like AI. Because if I let AI loose on a game engine code base, it's going to have no clue what to do. I've heard the argument of like, what if a big corporation takes your engine then runs with it? And I'm just like, no. The biggest example of this would be like Chrome, I guess. Everybody still mostly uses like mainline Chrome, and nobody hides that any of their stuff is a Chrome fork. It's like obvious. Like this is Brave right now. This is a Chrome fork, but like I'm still using Google services. I'm still using all of that stuff. Honestly, if a large corporation takes my engine and then runs with it, good. I have accomplished my goal of making it, like, forcing the industry into adopting a certain paradigm. That is my goal. My goal isn't to, like, control and own an engine. That would be pretty cool. You'd get a lot of power from that. But that's not my explicit goal. If my goal was power, I'd be making people pay me. But yeah, no. If a corporation were to try to clone this, they would have to make it better than I make it, and it would take them a bit to actually reverse engineer it to the point where they're able to do that. At that point, they'd probably just try to hire/acquire me, and then that comes down to like, I'm probably acquired with the engine, if it is acquired, which I don't know if that ever happens, because I'm really not a fan of meta, and they'd be the main ones interested in doing that. They'd have to make an extremely compelling deal. And that would be hard, because, like, money doesn't really affect me. It should probably affect me more, but like, I see large numbers, and I'm like, cool, those numbers are big. But, like, are you gonna make my thing crap and, like, die when you acquire it? Yes. No acquisition. We have more contributors because people are interested? Yeah. They'll probably go like, oh, how did Facebook suddenly go from Horizon Worlds to something that works? Oh, it's Apache 2 licensed. They legally have to credit the original project. They can do whatever they want, but they do have to credit the original project. It's a legal requirement. It'd be a very fun law case if they didn't. Okay, back to this though, because before we fantasize about how, obviously successful this is going to be, we need it to work. It needs to exist. Okay, so avoid manually handling stack versus heap values. Now, the thing about this is how do we handle... one thing I would like to avoid is stack pages. We want our JIT backend to handle we want our JIT backend to handle accessing. Wait a second. See, here's the thing. For pointers to work, the way that we would pass a reference into a function, for instance. Okay. If we want to be able to pass a reference to a function, that reference needs to use our pointer format, which is incompatible with the normal format of pointers in the thing, which means we cannot rely on basically we need to heap allocate anything that we want to reference. That's the way it has to work, is we must heap reference everything. So structures are heap allocated. Now, do they have to be allocated on a stack or on the stack? Well, we can't, because pointers do not support that. Do we want now we only have to heap allocate them if we only need to heap allocate them if we need to reference them. So I'm gonna say structures are heap / arena allocated lazily for references, or lazy allocation for references. Rust is good. Another one for the Rust cult. But yeah, we want to lazily allocate structures for references. Can I afford to do lazy references right now? If we want to compile fast, get compilation working quickly, I can't lazily allocate structs. Or can I? Depends on how we handle structures and enums. I don't want to define a runtime level union type. But I don't have to define a runtime level union type if I just define it as a structure and then allow. See, then I have to like treat structs as simply memory accesses, and then it's like regular memory accesses, but I do kind of want structs to be SSA form in a sense. Lazy allocation for references. And by lazy allocation, I don't mean in the compute sense, I mean in the they aren't actually allocated unless we need them to be allocated because we're referencing them somewhere. Now, I'm kind of wondering if I should just ditch the LLVM backend for now. Because if we're going to completely redo the, how many lines of code is this? 800 lines of code? That's a lot of lines of code to just throw away. But I am like completely going to redo how this actually works. So it makes sense to, yeah. How much of this do you want to be used? Client side versus server side. You mean like the scripting language? I want it to be used a lot on both. So one of the things I really want to let people do is script server behavior. Like server-side only scripts. I also want to allow like rollback networking, which means running the exact same scripts on both the server and client at once. And of course you have like your aesthetic client-side only scripts. So it's kind of like you have your server-side scripts, which probably run less than the client-side only scripts, but scripting everywhere. Scripting everywhere. So we need to have a malloc instruction. And malloc instructions can become more complicated eventually. Probably want unions or joins when it comes to databases for the server side. I'm not sure what you mean by that. You mean like the collection, like unions and joins, like for set data types? So like a standard library thing, but that's not like a at the runtime level thing. And manual allocation is like frankly very easy because you just use the malloc intrinsic. So I'm left with main barrier. Main barrier right here is that secure. We need to pass secure pointers into functions, not actual pointers. And we want to be able to reference structs. Well, we want to be able to access structs that aren't in that memory space. So yeah, we do... Do I use malloc for that too? Like when we reference a value, do I just malloc set all the values and then send it off? Like just send it off. Or oh, what I could do is just force people to always malloc structures explicitly. Well, not always. Just anytime we pass it into a function. Make sure that it's a pointer. See, what I'm trying to avoid right now is needing an explicit stack page system. Because I don't want to have to keep track of that and pass that to functions. Because then I also need a stack pointer separate from like the actual stack pointer and everything. But I also don't want to like semi-garbage collect it, where it's just like every object is allocated on the heap. But that is kind of looking like it's what I'm gonna need to do. I'm briefly considering you're able to allocate structures not as pointers and like as ephemeral values, basically. Like being able to return a struct pointer like this. Like structs are just always pointers. But what if a function can just So if we get into a situation where we want to do something like my enum C equals A, like this. I'm having to like unrust brain myself right now because we're making a simple language. And I want this to be a pointer. Do I want to switch to... I like this syntax because it's like a pointer to this type rather than a type pointer, because like this you basically read it backwards. Like this is a pointer to this type. Whereas if you say this, this is a pointer to a pointer, and then it's a type. I think that makes more sense. Do I implicitly malloc this? No. Oh no. It's kind of making sense for every single object type to always be represented as a pointer. C++ for C. But it just feels so wrong to just like let values escape into the void like that. Let's see. And if I'm always gonna say like, if I'm always going to have these things be pointers, Oh, I need to turn this into... I need to turn the results of these into enums. So this would need to be like new my enum. I think I'm doing just dot syntax, kind of C#y. Not my struct, my enum. Load. In this case, b is an int, so I need to turn that into a float, which can be done two ways. I think that syntax makes more sense, but it could also be a member function. This also needs to be new my enum float add float a and this would be something like new. Actually, yeah, for that I do kind of have to do, I do kind of have to add an operator for that. Int AB, int add AB. Yeah. Okay. I'm not a huge fan of this. Because it requires some runtime stuff. Now, we're arena allocating, we are not garbage collecting. So basically at the end of every pipeline stage, we take the reference we are given, if it is a reference, if we are returned a pointer from a pipeline stage, then we recursively go through that object, because the BraneScript runtime will have the ability to do reflection stuff, and hopefully rather quickly. It will at least have one very fast function, which is give me every single memory reference that this thing has, and then just collect all of that memory. All the memory that we're exporting. Save that off to the side, and then yeah, we have all the we have all the memory we exported. Or at least we have references to all of the pages. Not necessarily the specific memory objects. Yeah, which is kind of like garbage collector stuff, but it's like I don't want to make this super hard on myself or others. So I guess I do kind of have to do like faux garbage collection at pipeline boundaries. So, runtime concepts. Is BrainScript gonna just be scripting for the engine, or was the engine gonna be written in? So the engine is going to be written in Rust, but I'm gonna write as many of the engine features in BrainScript as I can. So UI, for instance, I plan on having all the UI for Brane Engine written in BrainScript, if that makes sense. Because BrainScript, I'm planning, is going to have hot reloading, which would make making UI a lot easier because you just hot reload the UI scripts. Yeah. So runtime concepts. Since our malloc calls are going to be initially non-locking, like we're going to have the option for very fast memory access. Hello there. We're going to have the option for very fast memory allocation. The problem I'm worried about is the correct word marshalling? Involves converting an object's in-memory representation into a format suitable for storage. Okay, so we're not doing it is kind of marshalling what I'm thinking of, because I'm thinking of like once the script is done, we want to nuke the memory. What is this project for? This is for a VR native engine specifically for runtime loading user-generated content. Thing is, I don't like all my objects implicitly being pointers. That feels wrong. But if allocations are fast, then it's fine. Mostly. I've just been saying garbage collector bad for so long that I am scared of garbage collector good. Okay. Structs. Cannot make references to non-pointer contained cannot make references to non-pointer contained data. It will basically do a cannot create pointer to R value error. But I want it to be a lot more understandable to that. Cannot create what that means is the reference operator kind of becomes a member reference operator. Cannot make pointer to val. Cannot make subpointer for non-struct member. Cannot make subpointer for non-struct member. Is going to be our error for the reference operator to non-object member. That basically means if we do something like int a equals 3, this means we cannot create a reference to a. We need to pass it directly into a function or call allocate on this to create a pointer. Which means, yes? Yeah. Streaming with a camera on. That was it. I love it. Good I have parents that like me. So that's what we call a W. Alright, let's see where. There we go. Okay. So basically, we'd be able to create. We would not be able to create a reference to this because it's not a value that actually exists. Indeed. Okay. Cannot make references to non-pointer contained data. All objects are allocated with alloc. Alloc will have arguments for quick or the type of allocations. It should do fast versus exported, for instance. Okay. I'm not sure what secure allocations look like, but we'll figure it out. For the moment, we'll just do only fast allocations. And I don't think we're going to have a... We're not going to have a free function. Basically, you will continually fill up memory pages until you're no longer referencing values in there, and then the memory page just gets dropped as soon as it's no longer referenced. And that is the plan. Okay. How do we figure out if we are still referencing a memory page or not? That's kind of something that's kind of something for me to figure out when I'm writing the runtime, not necessarily for when I'm compiling. So, runtime decides what memory pages to keep alive. All we know is that the memory is being kept alive. That memory in that is referenced will stay valid. So it's basically page level garbage collecting as opposed to page level garbage collection as opposed to Brane, work with me here, object level garbage collection, which I hope is more efficient. But it'd be so funny if I make it. I'm just like, oh no, garbage collection is the best solution. I kind of have decided on that for a while, but like, Soon to be amnesiac. Yep. Okay, so... reference is basically a get me a pointer to this member operator. That performs an add. That is something people are going to be careful about, is not to do addition with pointers, because I am going to allow addition with pointers. Did I do a dereference? How do I keep this as this symbol? There we go. Do I want to allow people to set pointers directly? Or... Or treat them as references? I am undecided. This is dereference is the hardest thing to deal with for me on the compiler side, because behind the scenes, what a dereference means is, like, it can mean two things. If it's being used in the context of assigning something, like if you're saying star variable name equals, that means set the value of this thing. If you say star and then an expression, but then you use the value, that means give me an ephemeral value for this thing. So it can mean two things. It can mean the literal address of the value, yeah, it can mean the literal... When you're making the compiler, to set something, you need the pointer of the memory that you're setting. Like, you need the... Yeah. Yeah. Okay, let me just write this out. So when you assign a variable, 3 things can happen. There are 3 things that can happen when you assign a variable. The first thing is that overwrite, let's call it ephemeral. Good night. If this is an ephemeral or SSA value, so something that does not exist as a memory address anywhere, values are overwritten. This is fine because of the jump lift style. This is fine because of the crane lift style jump abstract. This is fine because of the crane lift style jump abstraction. Because you don't have to use that SSA value anywhere else. The jump commands automatically hook all that up together. Now you could just set the memory referenced by a pointer to a value. That is also something you can do. Or set a pointer to a new pointer value. Now, in this case, this is also an SSA overwrite because you're replacing a pointer with a different pointer, like changing the pointer value. The issue with that is like, okay, what if I want to set the value the pointer is pointing towards instead of the actual pointer itself? And since at this stage in the compiler, it's going to be statically typed still, we would be able to tell, are these compatible types? And if we try to set a pointer to a pointer, then just overwrite the pointer, locally, or if this is a that the memory referenced by a pointer to a value. Set the pointer to a new pointer value. And I am struggling so much right now because I'm like, this is like, like, all these different scenarios are flashing through my mind of like, oh, this is why like Rust is written this way. This is why functional programming languages are written these ways to avoid all these bugs potentially are going to be caused by this. I know that right now I am spawning so many future bugs because like people aren't going to understand how this system works and it's going to break and like references and or I could go a different direction. Which is when allocating structures, at first, they're basically a tuple of all of their values. Like, every single member of the struct gets an SSA value. And then when we try to reference that structure anywhere, we just allocate. We just allocate. We don't care. We just allocate. This is so easy if I just use this, like... I really don't want to implicitly allocate all objects. Always. I hate that. Like, I genuinely hate the idea of implicitly allocating everything. So I still do need to do... Okay. I'm going to do a potential foot gun that I think is worth it. The reference operator is an alias for fast allocation. That is what the reference operator is. This will make a call out to an intrinsic function that will be statically linked, so it will be pretty fast. It will be a function call. But referencing things will allocate a reference. The reference for fast alloc, if the object isn't contained referenced value isn't in a page already, which makes me think we should have a method for... We should definitely have a method for deallocating stuff, because I could see fast alloc, like, very quickly filling up memory pages. Like, very quickly filling up memory pages. Especially on, like, long for loops. It would just be a memory leak. But if I think about it, it might allocate a ton of memory, but then that memory just gets thrown away, and then we're good. So I'm not going to worry about it for now. We might have a dealloc command eventually, or like a free command, but mostly it's like a allocate and then forget, and then when the pages are no longer referenced, they're dropped. So if you have a function... No, yeah, if this is actually doing optimized stuff, you do not want references causing actual allocations. Okay. Problem is, we don't have the concept of lifetimes. We don't have the concept of lifetimes, so we could just make alloc mandatory. I think that's what I'll do, is just make alloc mandatory. Yeah. And I think I'm going to keep the cannot make references to non-pointer contained data. I think I'm going to keep that. We're going to have that. I do want allocations to be intentional by the coder, so maybe I'll just have a pointer intrinsic that does allocations. Runtime value. Runtime decides what memory pages to keep alive. All we know is that memory that is referenced will stay valid. And then I'm going to say objects may not be returned from functions, but they may be passed to them. Each object member is a separate argument. They essentially just get split. And then an exception. An exception might be made for structs that can be packed. For small structs that can fit into multiple registers or stack slots, CraneLift can present them as multiple individual return values in function signatures. Particularly efficient as it avoids memory allocation and allows values to remain on the stack, which is more amenable to optimization. It's actually amazing. The returns field as a vector, allowing for the specification of multiple return values. Okay. Isn't allowed to return more than 3 values. I think for compatibility, for now we'll keep it with objects may not be returned from functions. Or maybe enums. It might make sense to return enums. I'm gonna say we may return structs that are less than and 64 bits in size. I think we're only targeting 64-bit architectures, right? 64 bit. Is 64 bits. Yeah. As we may return structs that are less than 64 bits in size by packing them into a single register. So we basically need to do a an object size check whenever we return just a raw struct value. So this struct here this should give us an error that it's too large because my enum actual no, 32 bits, 32 bits. If these were 64 bits, then the structure would be small enough. If they were 16 bits. I don't think I defined a floating point 16. That might be a case for 16-bit floats. Anyways, this will have to be returned as a pointer. You assign a variable, 3 things can happen. Ephemeral SSA values are overwritten. Set the memory referenced by a pointer to a value. This requires type not type knowledge. Requires knowledge of what of previous operations. Because if the next operation was a dereference at any point, if the last time that value was mutated or referenced was to dereference it, then we want to set the value of the point. Yeah. I guess, like, in an expression, you'd want... We basically need to do place versus values. Place versus value expressions. Tell us to either do we want to set the pointer or do we want to set its value? And I think now that objects are not implicitly pointers, then having, like, if this is passed in as a pointer, this needs to be pointer A equals to, you know, affect it. And that's fine. I'm fine with that. As long as it's just not, oh, everything's a pointer, so you always have to type this syntax on everything. Have fun writing Brane script. No. Okay. When objects are not allocated, they're stored as a set of labeled SSA values as opposed to having an actual store presentation. Member accessing or setting members in this form treats them as regular SSA form variables. Just with a path to access them instead of a single label. Makes me realize we could do optimizations where people can turn a structure into like an SSA form structure, an ephemeral value, do a bunch of edits to it, and then after that, after doing a bunch of edits to it, they could reassign the struct to its old value, and you could check if this is the same value that we originally got this from. Only do store operations on the members that only do store operations on the members that were changed. I think that's too much of an optimization for now. We'll just be like, okay. IR is emitted lazily. Yes, so when building IR, we use closures and define every possible thing that a thing further up the tree might need from this the current operation. The thing further up the tree that something using the result of these operations might need. So that the grammar that comes later can choose what operations previous grammar is evaluated to. All right. And that's the fun part about SSA form graphs. IR is emitted on the block IR is emitted on the level of blocks but the lazy emittance can span. I don't know if the lazy evaluation affects multiple blocks. Depends on how the joins are set up. You know, as long as I'm okay with larger binary sizes. So having duplicate operations inside of IR is fine to me. Absolutely fine to me. You gone, viewer bot. IRs evaluated on the level of blocks are still in scope, so we can laze construct so we can lazily construct jump command arguments. Yeah. we should be able to make conditions for blocks that handle, because we're not going between function calls. We're just doing while loops and switch statements, which means while loops are super easy to handle. Jump commands for that, and switch statements don't loop. So yeah, so block creation for that is super easy. Okay, as long as I remember. Oh, I need to design the IR now to support all this. Specifically blocks. I need to add the concept of blocks into the intermediate representation. And then once we add that, then we add jump commands and conditional jump commands. And then we're good to go. All right, I'll be right back. Okay, it is time. After 3 hours of planning and yapping, we get to actually code. Come on, MacBook. There we go. I need to be able to see chat. Thank you. Oh. First step. So this is an unconditional jump. Let's see the... There should be jump commands in here, right? See, there's a loop. Okay, so Wasm just straight up has... Right, because Wasm has... Yeah. It has actual control flow inside of it, instead of the more generic thing that I want to do. Okay, let's see... Crane lift... Instruction builder. Want instruction builder. And we have jump. This calls branch if and branch table. You know what? I am going to straight up steal that. Indeed, JIT compile. Well, the actual language looks a lot more like C right now, though it is slightly oxidized. Okay, let's call this... Yeah, I can call it that. Break if... And... Are you using CraneLift? CraneLift is one of the backends that I want to target. Currently, I have an LLVM backend written. But I plan on making a CraneLift backend and have them be, like, toggleable. So I'm trying to use, like, a good Venn diagram of the two different compilers. I like the abstractions that CraneLift has, and I kind of, like, I have to conform to them. So with CraneLift, I'm kind of following it for my intermediate representation that I'm writing. No, LLVM has just-in-time compilation. Look up it actually has two just-in-time compilers. So there's LLVM ORC, which is on-request compilation, which literally a JIT, and then there's a different one. It's a different one. There's a different one that isn't ORC, and I think it might be what ORC is built on top of. It's slow if you're getting it to optimize. I am not really running LLVM optimizations, though. The idea is that once the script actually compiles, it's super fast. Just walking the LLVM trees? I wouldn't know. Let's do break. You know what? We're gonna name this understandably. And this has this jump table. So we have our jump condition, which most likely will be an enum. value. Note that this branch instruction can't pass arguments to the targeted blocks. Can't pass arguments. So, like, if it can't pass arguments, how is it supposed to use any variables from before? Maybe I need to understand how call args work better. Unconditionally jump to a basic block, passing the specified block arguments. Let's understand blocks a little bit more. I would, but I want to target multiple platforms, and I don't want to have to hand-roll ASM for Android. Which I guess is just ARM, and ARM is, like, tolerable, but no. Great jump table. Used by the break table instructions. Instruction builder. Break table. See, now I'm really confused. It's like, how do blocks work? Are arguments only for changeable data? Are block arguments only for like SSA form data that can change? Do you have the C front end finished? Mostly, yeah. Right now, I just need to... Well, I guess it depends on what you mean by front end. I have the parser down. What we're working on right now is lowering to an intermediate representation for serialization. And then this representation is what we'll use to plug into either LLVM or crane lift. So, kind of. It's half done. Right now we're working on it. Will I have an interpreter of the intermediate representation? I'm not planning on it currently. Currently, I'm planning to only have JIT compilation of it. So if you try to run it, it JIT compiles it. I have an intermediate interpreter. Oh. Might be jittery. Some JITs will only compile a function if it's hot or loop is ran 5 times. Not if everything's compiled before you try to run it. There's a decent chance I just end up using crane lift for everything instead of LLVM. That means I need to figure out how jump table works. All these take block call instructions. And this allows you to append arguments. Rust is amazing. What do you mean? I'm not actually asking. I'm not going to listen to anything you say negative about Rust. Because the vast majority of criticism I hear about Rust is just, can be boiled down to, I don't like writing it. Yeah. I'm like, that's not an actual, like, argument against the goodness of a coding language, in my opinion. Now, is it nice if it's nice to write a language? Yes. Does it affect the output of the binary? Not really. Well, maybe, but not really. Not in case of Rust. If it's like a language that you need to remember a lot of stuff in, then yeah, then it does affect the binary, because you're like, I don't want to be writing this language, and then you don't write enough of the language, but Rust forces you to write those parts of the language, so. "50% of the code written is a piece of checker." That's the point. That's the point. This appends arguments. Like, yeah, block calls. How do WASM time jump tables? How do the blocks inside of jump tables access previous data? Because they must be able to access previous data. That's like... See, once you do all the proving, you know that it's been proven. And most of the time, you find something wrong. Anybody who complains, like, have you used C++? Rust is to solve C++, and Rust is better than C++. If you complain about compilation times, it's like, Rust compilation times are about the same as C++, maybe faster if you include how long it takes to manage all of your dependencies. And build those, usually. I've never gotten the argument that Rust is slow to compile. It's always been one of the faster compiling languages. In my toolkit, when I'm not comparing it to just straight up interpreted languages. And even then, like, if I'm using like a React framework, those things can take forever to compile too. Sometimes longer than Rust. And after you have like your compilation cached, because it caches, then it like compiles pretty instantaneously. This is better than C++, but that's a low bar. C++ is what everybody uses if they're not using Rust or like super hardcore. So yeah. Just look up block. Wait a second, are blocks? Blocks are just able to access previous arguments, aren't they? Or previous SSA values, aren't they? That's just how this works. Yeah, okay. So the only reason you need arguments is if there could be different values going into a block. That makes sense. Yeah. C is annoying. But then that's the thing, that library was not meant to be multi-threaded. Or was not designed to be multi-threaded. So it's kind of like saving you in a sense. Because what if you tried to do multi-threaded calls to a library that's not multi-threaded? Except they add multi-threading, except for that one part. That makes me think that part of library isn't meant to be multi-threaded then. Like I said, I'm going to be an unashamed Rust apologist while also making my language that isn't Rust. I was making like, before this version of the language, I was going like fully down like the dependent types functional programming route. And then I'm like, I'm not going to get this done this century. So, need to switch to making a C clone. that does not do any static analysis except for type checking. But it is good that I spent that much time staring at blocks, because that means it's good that I spent that much time staring at blocks, because that means that I have to format this all differently than I thought I did. I was just going to make like a list of blocks, but I can't make a list of blocks because I need to be able to access values within those blocks from other blocks. But then again, what if IR value was just or you could make in IR values either a block operation, like the result of a block operation, I'll keep with my usual like structure method here. That's the block it's from. This is the operation the value's from, and the IR is in SSA form. So we have the block argument, which means this block is called from multiple different sources. And then, since I have this arg value workaround currently, what if I just said function arg value, or just function argument, 32-bit integer. And then instead of having function arguments be like one of the SSA form values, I can just put them in here. Or I could actually put constant values in here too. Wow! Since they're not actually operations. This is a lot cleaner. You know, while I'm at it, we'll just do 32-bit ones too. Nice. That makes this a whole lot cleaner. I like that a lot more. And now we have our operations, and all of these operations are every single one of these operations are 100%. What am I looking for here? Brane, work with me here. All of them are operations instead of constants, like some of them were. Okay. So let's say function in here. And we're gonna have blocks. And this block is just going to be block. Played around with a binary yen. I recognize the name. 1 second. WebAssembly binary yen. I was playing around a lot with the idea of using WebAssembly instead of writing my own scripting system a bit ago. I feel like I might have used this before. Yeah. Maybe. Compiling to WebAssembly. Anyway, I've seen the name a bunch of times. IR op. Okay, so I didn't rename this. Do I keep... I'll keep this as IR. Actually, no. Consistency. We do a little vibe coding. I don't actually care about the debug output too much, and that's a lot of boilerplate. So we can just like burn through that. Do I vibe code this too? I might vibe code this too. This is just a display. Okay, and did I reduce the indentation on this? 1, 2, 3, 4. Okay, yeah, there's an indentation difference, which was my main concern there. What is it complaining about? Method defined here. It's the only diagnostic of that. Okay. So I think now that we have blocks, conditional jumping, all of that stuff. How do I handle... Oh, wait, it's just pointers. So I don't actually need to, like, handle enum variants in any particular special way. You just function, like, cast the function pointer. It's fine. Cast the function pointer. It will be fine. Nothing will go wrong. Okay. 12:20, and we have what I believe is like a pretty solid form for our intermediate representation. I'm not sure if I want to make specific sizes for all of our like addition operands. Most backends don't have size specific add and whatnot operands. This is the function builder. We need instruction. Maybe if I just back, no, go back, no. There it is. Yeah, it's just floating point addition. Oh, it even works for vector types? Okay. Yeah. I would have vector types as a different function call, but yeah, this is fine. And since I'm not doing the thing I was doing before of it just said to debug format. It also escaped the bounds that I told it to, yeah. I did just say show input. There we go. Thank you. That's what I didn't want to write. Wait, there's a join? Like that? That's not how I would usually do this. I wonder if that is more more efficient. I don't know. You know what? I'm gonna go with maybe that is more efficient. Oh, you does implement display. Don't know what this is on about. Still. We'll figure it out eventually. But yeah, let's make a compiler. And I have a lot of stuff here that's like my ideas about how I want the builder to work. I think I'll just reference the... Because yeah, there's stuff here to like handle subtractions and whatnot. But I think I'm gonna do... Actually, I know I'm gonna do that with intrinsic functions now. So all of this... Basically, we don't need any of this. That's just copied from an old system. Okay. Only thing we care about is emitting functions at this precise moment. So, actually no, I do care about structures and enums because that's what our demo uses. So we do need to implement everything. I did not give myself an easy out. We don't need to implement linking or namespaces for now. So we'll just ignore those. But we do need to implement the ability to emit all of these. Can I use... Okay, so I need to think about my lazy value emitting system. So we have this IR builder. Actually, we'll go with function builder, since that's what it is. And we need a list of function arguments. I'll also put this up here, a type builder. And we also need a like expression result, basically. And I might just use AST types, if I'm being completely honest. Where are you, parser? There you are. Means I need types. To have partial equal, as well as clone. This one can have copy. And then with type, we need to not take into account whatchamacallit, the span. Because we don't need spans to match up. we also need path to implement clone? Oop. Yeah, let's move this down to here so that they're next to each other. Oh, wait a second. Ident. Template arg. Do I need a box around path? Since path has paths. Oh, wait, vector. Okay, so yeah, we're good. Oh, here's the type. This needs clone. There we go. Okay, so now I can just use equality clone on type statements. Perfect. And there's other optimizations I can do to that later, but we are not optimizing, we are going. Okay, so what do we put in the function builder? Hmm. So I have an operation builder. Sorry, I got sidetracked thinking about the functional programming language I was going to make and how like tail calls work and all of that. Anyways, operations. We need to look at, nope, this panel. All of the different operations. We can do. Which, thinking about it, dang, I'm just stuck on like lazy evaluation. Okay, the vast majority of these are going to be handled by intrinsic function calling. Basically all of the operators. So everything from here down to, I want to say there, all of those we don't have to make a compiler representation for, because they're handled by our intrinsic. They're going to be handled by our intrinsic function system. I don't want to have to create classes for all of this. Okay, for the compiler, what are the different things we're going to need to do? The hardest thing is label resolution or identifier resolution. Especially in the case of specifically loops, because, like, I'm not quite sure how to handle having a value that we aren't assigning. It's an SSA value, and it's assigned in the loop every single time. Because after we've done a full iteration through the loop, we need to figure out what references to that label, like what was the value at the, where's the value first used and where is it last used, and then change the first usage of that value. Well, actually, it's pretty easy. Actually, no, it's not. Okay, find the first and the last instance of the use of that value, and then find the first and last usage of that label or value. Okay, we only have to solve this in one case. This is the only time we ever need to solve this. We don't need to solve it for pointers either. So while loop value Ouroboros. I know that's wrong. No, I wanted the other one. How do I spell it? Ouroboros. How does the loop consume itself? Track all labels passed into the loop. Track all labels passed defined at the end of the loop. So we're gonna say this. Track all labels defined at the before the loop. Track all labels defined before the loop. Track all labels defined at the end of the loop. Find labels that have a different value at the end of the loop to the start. change those values to instead be reference lock arguments pass the previously found last value into the pass the previously found last value into any jump calls. Actually, then from there, any jump calls is a chicken and the egg problem. Because now when we leave the loop, we also need to know when a block, if a block comes after the loop and it references a value that was changed in the loop, or we could create a finally block loop should create a block that wait a second. Let's see. Changed values should also be passed to exit jumps. Changed values should also be passed to exit jumps. then cold lazily. Change values should be passed to exit jumps and then cold when the jump is actually emitted. So this is where we need to be able to reference stuff. So function builder. We'll just have blocks in here. How does a block... Okay, let's say... Let's say block A has an argument, like this block is called from multiple different places. And then we have a jump table. So there's now multiple blocks that we can branch off to from this block, and we want these blocks to be able to access this conditional value. Are they able to access previous block arguments? Like, are previous block arguments valid game? That we're allowed to grab? Does that work? All of them to just directly say, hey, this block comes before us, so we're invariably always good to access that value. invariably. That's the thing. Since it's invariably, that means that when we do a block argument, we in fact need to know the block that we are getting the argument from, because we can get the arguments for other blocks. Okay, it's fine. It's fine. It's fine. I would prefer a phi node now. A phi node would be easier to deal with than this, I think. Maybe, possibly. I have no clue. Maybe it's just a hard problem to solve. Okay. Okay. The next block that we jump to actually no, if we're replacing values in the global namespace, yeah, if we're replacing labeled values in the global namespace, so you essentially have a double-ended queue. This is our scopes, like which scope are we currently in. Actually, if I'm going full C clone, that means you can't... I love defining variables with the same name as previous variables. But if we're going full C clone, then just... full hash map. With a... So I have the concept of a lazy function emitter. with the idea that code will only be emitted when we need it. So we're gonna have a thing called an expression resolver. We're gonna call this actually an expression value, because that's what this gives us. And expression value has two arguments. It gets two things: an emit value we get an ID, we get an emit value, which is a reference counted dynamic function, which takes an immutable reference to a module and then do we ever optimize out blocks? I don't think we ever optimize out blocks, so this function can have captured state of what block it should emit stuff into. Function, what function to emit into, is a runtime value though. So what about types? Does this ever need to emit types? I think, at least for debugging purposes, let's just emit all types even if they're not used. So all types are emitted, so we don't need to emit types. which means we don't need reference to a module. We need reference to a function, and we're emitting values into this function specifically. And then what this function returns is an IR value from that function. That IR value can be any one of these. And we're also going to have here emit value pointer. So this is a pointer to the value that is currently being looked at. And here's the thing. Since this can technically be called multiple times, we need a way to memoize the expression. That's the ID. Okay, yeah. ID. If when we go to actually emit everything, we just check, hey, has this expression been evaluated yet? Yes, no. I think we want to encapsulate this a little bit. Hello, how's it going? Okay. I'm going to attempt to see if I can get a one-shot vibe-coded prompt on this, just for the fun of it. Okay. Create an implementation impl for expression value. This should include a new function taking an ID and emit value function actually a value function that takes a reference to an IR function and a map of cached values. It should check its ID against the hashed values to prevent re-emitting. Do the same for a function called value pointer. Okay. Let's see how fast it does this. The other edits I've had it do were like super fast. No! I pressed escape. I didn't actually. Create an implementation for expression value. Create a new. What I should be doing here is doing like the Vontae ask, but I want to conserve tokens. So, create a new function. Create a value function that takes in a function reference, an IR function reference, and a map of values. Have it check its ID against the map and conditionally return either the map or the cached value or result of the emit value function. Do the same, but for value pointer. Okay, so now see, that's what I wish I did the first time. Yeah, it even like did an ID function call for me. I want this to be value and this to be pointer. Here, let's also add a oh no, I'm not commenting. But yeah, there we go. Wait a second. It didn't do the caching thing. That was the entire point. That was the entire point of the prompt, was I didn't have to. Return the value from the cache if it exists instead. There we go. And it even takes into account adding it into the cache. There we go. This might be all we need, to be honest. We don't need necessarily scopes. Okay. Yeah, we'll just have this be a function context instead. We'll have our IR function here. So we need a hash map from string to expression value, and I'm going to do clone on this. Okay, and then does the new take? Yes, it does. We don't need blocks anymore, we just need the actual function that we are currently working on emitting. Function values. The function can handle keeping track of all the blocks that we have currently in scope and the arguments. that it? Can't be that easy, right? Okay, so when we emit a function, when we go to emit a function, what should happen is this module should already have all of our types defined. That's probably another thing we need in the function context is our types context or module context. Yeah, let's create that. Actually, no, types are going to be... I'm going to be passing those around by value. Okay. We're going to have a namespace. We just need to pass the entire AST in, basically. But not really. Okay, yeah, it does need to be a module-specific context. Not module-specific? I'm gonna call it a namespaces context. And let's look back at the AST real fast. Because that's what we're working with now. So if we define a structure, it has all of this stuff. If we have a type, the type is resolved into potentially a path, potentially all of those things. So yeah, we need a definitions context. To handle all of the definitions. Is definitions a per module thing, though? I don't think so. I mean, there are things like aliases and imports. So there would be like aliases. So this would take us, and this is a module specific thing, this would take us from the local name for it to the global name for it. Yeah, whenever I have a path, I need to resolve that into an actual structure. So do I need to create a type? I do. Let's... I'll keep those there, just because why not? But I do need to create a the compiler side, like definitions for types. Okay, and this will basically just be native, and this can be IR native type. Actually, no. Oh wait, yes. Actually, yes. This should be IR native type. No, it shouldn't. It should not. Because IR native type loses compiler info, so this actually needs to be AST native type. Or a pointer. Basically, it needs to be exactly the same as type kind. Ideally including the spans. Slice. And then we don't want path. We want tuple. And this actually has a span of like, where was the type defined or from? I guess. Actually, I'm gonna go span list for now. The tuple is just vector of box type. Partial equal. And clone. So we allow for anonymous structures, but occasionally they're not anonymous. And that is the only difference, is that this one has strings. Okay. Okay, and this as a type. Public function type, reference itself. Reference the self type. Is my internet? Okay, my internet is crapping itself right now. But it looks like we're still uploading. Which is good. So that's all the functionality I need out of type for now. Actually, a new and then let's see if this works. Create an implementation of the from trait for type that for the type struct in method on compile context instead. That way we can do lookups on the path and attempt to find the struct or enum the type is referencing instead of just doing a static mapping. Does it take that in stride? Okay, that's actually pretty impressive. Okay, where is it trying to... What is Control-W? Okay, so it is Control-W focus. I accidentally just clicked yes. I haven't figured out how to review changes yet. Somewhere in here, compile context. Oh, it's just importing it. It's putting it at the top of the function. I was running cargo test on it. Wait a second. Did it actually come up with a... It might have actually come up with a working method with, No way. No way does it actually get one-shot something useful from a failed to call. Like... So the reason... So, before I just had, like, a junky local LLM model, so that, like, you know... It could write, like, boilerplate and whatnot for me. Let's see, let's go to my account, but I set up, like, the whole developer account. How much am I burning right now? Where is... Wait, is this? Somewhere in here there's billing. Go to my dashboard. Yes. There is usage. How much am I burning right now? That's not terrible, I think. So I've burnt 30 cents in the time I've been doing this. Anyway, I, like, accepted my fate, and it's like, you know what? AI is just going to keep getting better, and, like, I am significantly better at coding than AI. However, it can... Because I'm significantly better, I could just, like, dictate exactly what it should do to it, and then essentially just, like, like, micromanage an intern, basically. And that would probably be a cleaner use of time, a better use of time, than, like, writing everything myself. And I hate to admit that, because writing code is my favorite part of the job. But, yeah. Because it wrote this really fast, and this is one of the things I was worried about taking forever to figure out how to... That's an unwrap right there. And that's why you write your, that's why you read your LLM's code. Or else path was empty. Which it shouldn't ever be, but just in case. I'll just resolve type instead. All of these are just a straight mapping, that's fine. What is it ignoring? It's ignoring member names. I don't want it to ignore member names. Okay, the MacBook actually is getting close to dying. Let me try harder to find the cord for it. Which is underneath is behind the 3D printer. The laptop's plugged in. It wasn't plugged in before. It's plugged in now. So I know that I'm going insane. I didn't think I was, like, that level of insane. Yeah, we'll roll with it. We'll roll with it. It's fine. It's fine. The laptop has been plugged in this entire time. I did have to straighten out the power block so that it would actually start charging, but no, it's been plugged in this entire time. This, like, flimsy little Mac connector that loves to disconnect at the slightest provocation. I know some people love it. I despise it, but, like, I live in a family big enough that, like, I know nobody checks where their feet are, and they just, like, kick cords constantly. So I know that this is a normie thing that they like, but I hate that. Anyways, that was still connected. I don't remember connecting that. Okay. So this is not the correct way to emit errors for anything. We can do that later. Okay. It's actually, like, really easy to emit proper errors later. It just would be time consuming. Or actually not yet. Okay, so right now it's just doing a full path lookup. Account for locally scoped things. To do. Okay, that's actually what I want to do right now, is let's have the current namespace. We'll just do vex string. Should I make the intermediate representation pointers be type specific? Are they currently type specific? Wait, what's this? Why is there... Be gone. I don't want tests. I'm gonna have to start telling it explicitly not to make tests, aren't I? Okay, yeah, basically what I need to do now is I need to decide on how do we resolve identifiers. Alright, and we're gonna say add a function to compile context that takes in an AST identifier AST ident that a module context and then tries to find the definition. For that thing. Assume the same take into account the current namespace variable, which will include the current module name and never be empty, though still handle results. Also take into account module use statements, which act like C# use statements. Exposing their entire namespace. nvim cw. W. I don't know where it is. Oh, there it is. Okay. Use the value definition of an AST identifier, taking into account the current namespace, returns result, resolve def, and what does it return? I can't tell because my screen does not scroll there. There it is. Definition. Okay, it returns an AST def. That's good. Okay. Oh, I need to tell it to not do... I need to tell it to not make tests. Hello. We are becoming the scum of the earth. Vibe coders. Okay. Now where did it put the tests? Because it talked about putting tests. Alright. Oh, here's the tests. Right in here. Begone tests that you threw right in the middle of a different function. ChatGPT 5, by the way. Okay, so this... Why is this a member function of expression value? We want this to be here. That's obviously where it thought it was. So let's read through this, as you always should do. Segment. I'm just doing periods. Keep stuff as simple as possible. Oh, my Mac is my Mac going to sleep? Okay. I guess the sleep is different when it's on. Not found in namespace. Use statements. Oh, and our current use statements. Are we recursively doing resolve def? This should be passed in by reference for sure. Oh, why is it scoping functions? I don't like that. I don't like that. Does it work? Probably. Maybe? I don't know. No, I don't want to join current namespace. And this is just wrong, I think. Oh wait, this is the main one. Current namespace hierarchy. Okay, so current namespace. Updated module context to include the current namespace. If we're currently evaluating research may search content from inside a namespace. It will include the path to the module as well as the namespaces inside it. And the modules namespace. Actually, current namespace. I need a better way to handle loaded modules. Let's just not worry about other modules. I just haven't defined how I'm going to do that. Loaded is not namespaces. It's supposed to be modules. But I guess namespaces and modules are the same thing. Technically. Oh, I hate that. This probably works fine. Right through the current namespace hierarchy. I'll just go with a module namespace for now. Current namespace makes sense too. I'm also going to rename this loaded modules so it's more clear what it is. Okay, so this walks through all the current namespaces. So if I have current namespace empty, okay, this will function. This will function. Now in resolve type, instead of all of this, okay, we're gonna make this take a path instead of an ident and update resolve. type to fully use it. Okay, so we have a path. No, I don't want to. Okay, so we have namespace segments, path segments. Space path doesn't change. Nothing errors. Okay, now just restart my editor because the LSP isn't working. Okay. Out of curiosity, the problem with my LSP was in fact that modules we rely on have errors. I've been writing this entire time without error checking and I didn't realize. Technically not mutable. There we go. Okay. Now we have a module context. So in here, there's not a register struct. Okay. Okay, fine. We'll do this the whole thing. AE. No, not AE. See if it's able to handle this. It should be able to handle this. This, to me, feels like it should be able to handle it. It's using resolve type. Good. It is doing a lot more than I want it to. Okay, so it's just gonna be doing that forever. Got it. Okay. Actually do this correctly. Self-loaded modules insert. Module namespace. Clone. Actually, module namespace. Has to be a vec of string. Please join. know what? Screw it. We copy the entire AST. Because why not? Because it's not implemented. Yeah. Yeah, this function's kinda really crappy. What this should do is this should pattern match to the current path. For the moment, wait a second. I don't ever have to search other modules. I have use statements. That makes all of this a lot easier. In any case, that was clean. There we go. This is not implemented. Did I do that correctly? I did. Did I not make an enum type? I didn't make an enum type. Transpose. Please no transpose. Transpose scary. Okay, there we go. This is wrong. Okay, we're gonna have this be lazy evaluated actually. Okay. IR type by recursively calling the function. It should first check if the module already contains struct or enum. The requested struct or enum. And if so, just return a ref to that. All right, let's see this. So it's adding it to the top of the function. I don't like that, but we can put it in other places. Okay, so if it's native, just... Oh, right, because it's just a native type, so we can just copy it. Nice. This is a pointer, recursive, slice. There does not have a slice type. It does have an enum though. Should be represented as a tuple. Tuples are structs tuples are represented as structs without labels or names for their members. No, it's... Why is it giving tuples a name? When I the point of it being an option is so that tuples can... I'll go with yes for now. I think I already did it. Okay. Dario, check this. It's, yeah, tuple literally is just none. Wait, why does... Module doesn't have an abstract function. Okay. It's like a blind, entirely blind intern. Okay. reference IRRS and fix the emit type function in Brane C source librs. This is, I think this is still potentially faster than writing this from scratch. Maybe. I might be wrong though. Many assumed functions are there, and we're missing a case for slice. Wait. Yeah. Slices should be represented as a tuple with okay, see, it's actually doing two calls to check the code to see what it should be writing. Imagine. Okay. There we go. Here's the slice. I'll go with U64, it's fine. Dude, it's still... There we go. I like this diff. Why are there two emit type functions? The true power of vibe coding. You can have 3 of the same function. Function emit type. Which one is the correct one? I'm gonna give it one more chance to try to fix this. Wait. Yes. What is this? Okay, I'm gonna assume that the one at the top of the file. Okay, native. Yeah. We're gonna assume that the one at the top of the file is the most correct one. And go from there. I might change my judgment that it's time to switch to learn how to vibe code. I might have my job for longer than I thought. Should be able to do that. Yippee! There's... Nope. Nada. Okay, now... And then this... Yeah, I should add those. Should I make slice? No, we'll just make pointer. Is mutable and this. This is just 32-bit. Okay. Are strings going to be mutable? Most of the time, I think yes. We'll stick with true for now. Here we go. Turn the index to that instead of Look at this, it calls enumerate, and then it ignores the index. Oh. It ignores the index, but then it returns the index. I stand corrected. It's not stupid. It's actually smart and kind of clean. Okay. Yeah, GPT-5 will not be taking my job. It is taking my money, though. That one's going on twitter.com later. Wait a second. The only reason I had a compiler type? The only reason I had this... The literal only reason I had this was because IR types didn't support recursive functions. They now support recursive functions. Oh wait, but this is an inline thing, whereas intermediate representation version of it is indirect. Yeah. So we're gonna keep emit type like this. Okay, so we have all the boilerplate out of the way to go from structure from a definition of a type all the way down to the actual intermediate representation version of that type. So now, what we have left is nothing more than to just emit functions, right? We pass in the module context. Okay. So now we go through for every single definition. And let's just try to get a pipeline, or no, not a pipeline, a function working for now. Self emit function. We'll take the ASD function, the current module, to emit it into self function module context. Okay, so we now go for every single function. Man, it's the jump table. I just realized my AST does not account for comments. I don't want to have to rewrite my entire parser just to support comments right now. Okay, we are going to simplify this. This is all I want to get compiling by the end of the night, because I do want cogen by the end of the night. So I am reducing scope to just get this working. Just that one ad test. There we go. I feel like it would be useful to have non-mapped versions of types like that. I wish there was such a thing as a try map. But alas. Okay, we have our function constructed, and then in the module, I'm just gonna say module functions, let function ID equal that. Okay. Now here is where the magic happens. Potentially. Here's what I'm gonna do. Function context. Congratulations, you gain a lifetime. So now instead of having to pass two things into functions, we just do one. Nice. Okay. Let variables equal a new hash map actually that's values. For every single one of the parameters, we want to insert new parameter new expression value. Do all expressions have a return value? Most of them do. In fact, with the way everything works, no, it's okay for some functions not to, because they might mutate their input values. There we go, it's happy with that. Yeah, if it's an error, we don't need to cache it. There we go. Now we have a way to emit values. Why did it need to be satisfied? Very much a none value. I didn't do function once, I just did regular function. Why is it a function once? I haven't had problems with this in the pass. You're right. It does kind of need to be function once, doesn't it? Or it could be function once. Okay, I think I fumbled around with it long enough that it might be fine now. There we go. Yeah. So we're now at the point that we actually emit stuff. Emit stuff. You know what? I didn't say we run tonight, I said we compile tonight. And all we need to truly compile is an IR module. So let's... I've been streaming for nearly 8 hours. So, yes. For statement in statements. Um, Okay, we're almost there. We're almost there. One function left to go. Okay, and then we have a call. Yeah, I need to do a fair amount of work to expression value to also allow it to be callable. Because we have all of these, like, try to use the value this way, try to use the value this way. We need to have the ability to try to use the function. Actually, no, it's here. Try to use it as a value. Try to use it as a pointer. Technically, I should be doing... Technically, path is what should emit intrinsics. Oh, I have to implement literal. realized since this is recursive emission of values, it needs to be able to recursively call itself. Hello. Oh, is it getting to the point where people are waking up now? Here's that it is. Okay. We are very close to getting first IR module emitted from the new system. I've been out of water for hours. Okay. If path segments length equals 1, hello. Yeah, I have streamed long enough that everybody's waking up now. Hello, everybody. welcome to the 8th hour of the stream. We are roughly 5 functions away. Roughly, maybe 2 functions. This might be the last function. Away from first IR module emitted from the 4th rendition of Brane script. I don't know. Is it worth keeping track at this point? Alright. Context. If let some context values get ident text okay. And now go here, we go here. Okay. There we go. Now if we go back, would be correct. Cargo check. Arrow checker. How late for you is it at this point? It'd be better to ask how early it is. It's 5 a.m. Take 2 arguments. We ignore both arguments. Here. This is just a problem of the borrow checker. I've learned that the borrow checker literally works based on line number, basically. So splitting up stuff onto multiple lines fixes that, mostly. Ah. Wait a second. We can just throw these 4. There we go. Now you handle using functions from other modules. So at the moment, I think I'm going to take the route of functions are statically compiled, statically linked, whereas pipeline modules are not modules. Module pipelines are like dynamically linked. They're like, sorry, 8 hours of streaming. My brain is not working right now. I hit a wall like 20-ish minutes ago, I want to say. Yeah, basically, pipelines dynamically linked, functions statically linked, and then to do with the like actual syntax, it's going to be C#-esque of you do a use statement, and then that brings everything from that namespace, like it directly exposed in your current namespace. And then for linking to other modules, I literally just have like a link keyword at the moment where you just say link. Yeah. Have you ever written any JITs before this one? BraneScript is the only project that I've written JIT compilation for, but I've been repeat doing it for the last 3 years-ish. So that probably partially answers the question. You can specify if you want something in a module to be public or private to other modules. Eventually, yes. Currently, no. Because, yeah. Publicity modifiers are just like extra stuff I don't need to deal with right now. But eventually, yes. Oh, there's something weird going on with my screen there. Okay, we're back. Nice, okay. Yeah, of course. No, bring it back. Okay. This might work. Line 14, grammar error. But that is a grammar error from our example scripts, line 14 here. Okay, yeah. Expecting a semicolon. Ah. I had some of my musings in there. We're not doing new keyword. I scared myself by thinking that I would. Called unwrap on a none value. Okay, at least we get a line number. 512. Oh, okay. This is an easy fix. Blocks. Let's set it up with one default block. And it is interesting. Oh, yeah, that's the way the new intermediate representation works. Okay. Second real fast. Where is... There it is. I'm gonna open up Discord. I just need to make sure that, there we go. It's being weird. We go to Dev General, so I can go, hey guys. Guys, it's working. Okay, how many days ago was this? The 5th, so 4 days ago? Yeah. Yeah. Alright. I am 8 hours into the stream. I'm gonna go to sleep now. But I did say the stream title was Compile Tonight. The sun has not risen yet. So I'm calling it complete success. It compiles. Because this is technically the compiler. The backend, we don't need to worry about the backend. We can ship this. This is a shippable delivery. We're just gonna completely ignore the fact that, you know, like, it doesn't actually compile. We need to completely refactor the backend now, because they changed the way the intermediate representation works, which means we might as well just like switch to crane lift right away, and just not care about LLVM because it's a giant pain all of the time. And also that means that we can potentially compile the quest right away if we just switch to crane lift. We also don't have to do unsafe function calls because I do that currently. Alright. I'm gonna go eat food and then sleep.